Hello, geometry students. I'm excited to say that they found coverage for me this afternoon, so I'm making a video here to help you get started on and then show you the solutions of the do now, and also explain kind of what you're doing for the main assignment for today. This first shaded area problem is one that calls back to November when I taught you about how to find the area of a sector. Remember that you had to do theta over 360 times pi r squared, and you know the radius is 26. And let me remind you that the radius is the same in all directions. You also have enough information here to deduce this length. And what you're really looking for is theta. And you're going to need to use trigonometry to find this angle here. Let's call it x. And I'm going to remind you that you're going to need to use one of the inverse trig functions, either inverse sine, inverse cosine, or inverse tangent. For the second one, what we have here is a quarter circle, and then there's a triangle embedded in that quarter circle. And what I think you should do is find the area of the quarter circle and subtract the triangle. But what's missing is the length of the base of the triangle. And that's what you need trigonometry, is to find the length of the base of the triangle. Teacher, could you please pause the video now and let the students work for 5 to 10 minutes, and then you can start the video up so they can see the solutions. Okay, so now let's look at the solutions. So I'm gonna first find this thing here, and I hope that you realize that this length that I'll call red is 20, right? And that's just using 26 minus 6. So to find x, I know I'm going to use a trig function. Think in your head, which one is it? Well, it's cosine, because cosine is adjacent over hypotenuse. And so the cosine of x, whatever it is 20 over 26. And then in order to get x by itself, you would use the inverse cosine, because that's the function that cancels out cosine. And so you do the inverse cosine of 20 over 26. And x then is about, I think it tells you that it's, I have it written down here, 39.72. But let's just round that up to about 40. And that means that theta is 140, because that's a linear pair, right? So then we go to actually find the shaded area, and you would have used 140 over 360 times pi times 26 squared, and you get approximately 1,651.78 square centimeters. Did you get that? Because that's what I got. I think I got it right. I hope I got it right. Let's look at the second one. Of course, if you're going to find the area of the quarter circle, right, the area of the quarter circle would be pi times the radius squared, but then we'll just divide that by 4. And so the area of the quarter circle is, let me give myself a little room to work here. My calculations earlier told me that it was 254.47 square feet. But then we have to find the length of the base here. And so I hope that you realize the base is opposite and 18 is adjacent. So you would use the tangent function in this case. And the tangent of 37 degrees is equal to the length of the base divided by 18. And so I'm just going to multiply both sides by 18. And I'm just going to, convert this to a decimal for the sake of today. So I figured out that 18 times the tangent of 37 degrees is 13.56 feet. And what that tells me then is that the area of the triangle is going to be 1/2 times that number that we just discovered for the base times the height, which is the radius of the circle, which I discovered to be approximately 122.08 square feet. And so we have our two different areas, 254.47, 122.08, and then all you do is you subtract them. And so the total area that you were looking for is 132.39 is the number that I have. If you have anywhere that's in the neighborhood of 132.39, if it's 132 up to 133, then you did it correctly. Our rounding is just different, I think. So now to look at the work for today, I just want you to know it's 6 problems, and most of them have diagrams included. The first one doesn't, but they're all just applications of trigonometry. A paint crew's purchased new extension ladders. Oh, it's a ladder against a wall problem. We've seen these before. And so the safest placement is to extend it to 25 feet long and position the base 6.5 feet from the wall. So here we go. There's a wall. The ladder's 25 feet long. What's this angle, right? So that's you just use trigonometry to find the angle. This one I wanted to just briefly talk about because it says, what is the angle of depression? The angle of depression and this angle here, the angle of elevation, which you've never seen before, those are congruent. And the reason that we know they're congruent is that these lines are parallel and those are alternate interior angles. So there's enough information in this diagram to determine the measurement of this angle, and then you know that it's congruent to that angle of depression there. The rest of them, I hope you can figure out based on the diagrams. Some of them are quite challenging. The substitute or whomever is in the room with you will have a solution key, and they can show you all the solutions at the end. I hope you have an excellent midwinter break. I will miss you, although I am excited to be leaving. So I will see you after break. Stay safe, have fun, and be cool, and I'll see you soon. Bye.